Hello, grade 12B. Right, we're going to continue with our work on area and volumes of 3D figures. We have done the triangular prism and the rectangular prism. Now in figure 3, we see we have a cylindrical prism. Now what we require in calculating the area and volume of a cylindrical prism is the radius and the height of the cylinder. Those are the two most important uh, variables or dimensions that we need in finding the volume and area. And remember that the radius is equal to half the diameter. So don't forget that. Now, if you look at the figure that you see before you, you've got a cylinder that is 20 centimeters by 5 centimeters being the radius. It's drawn from the center to the circumference. To calculate the surface area of this cylinder, I'm being provided with the formula, which is 2 pi r squared plus 2 pi r capital letter H. Now for the cylinder here, we know that we've got the radius and the height given to us, right? So we're going to use those two dimensions to calculate the surface area of this cylinder. If we substitute into the formula, we know that 2 times pi, now pi is given as 3,142 times r squared, which is 5 squared. That completes the first bracket, plus 2 times pi, 3,142 times r, which is 5 times h, which is 20. So looking at the answer to that, it's very simple. So there we have the substitution, which must be done accurately. And we determine the area to be 785,50 centimeters squared. In terms of physically what this means, it is the amount of packaging or gift wrap paper we would use to cover the cylinder completely on the outside. Good. So now let's look at calculating the volume. As we stated previously, the volume of any object is equal to area of base times height. Okay, and in this example, if we look at the volume, the base is circular. Okay, the base is circular, and so the area of base will be pi r squared times capital letter H. So coming back to that there, we would see that it is 3,142 times 5 squared times 20, which is 1,571 centimeter cubed. What does this mean? This is the amount of liquid that can be poured into the cylinder right to the top. Now, these two calculations are based on a closed cylinder. My question to you, if the cylinder was open, how would this affect the surface area and volume? I need you in your activity time to discuss how would you calculate the area, surface area and volume of the cylinder if it was closed, open. Good. So we have covered three big three-dimensional objects in our lessons thus far. On your worksheet on page 2, you would see that there is a statistics question given to you, which is part of your syllabus. It is good to revise this uh, this question, yeah, so that you keep fresh with your stats work. Remember, this was what we did in the first term, and if you recall, it was the box and whisker diagram, and it pertains to quartiles, mean, median, and mode. Okay, we are going to move on onto our next page. Right, welcome back. We are looking at page 3, and in this page here, we see that we have various shapes of which I would like you to practice in determining the area of these shapes. If you look at figure 1a, it's a right angle triangle, and if you recall, the area of a right angle triangle is half base times height. Figure 1b, that should be a rectangle. Make sure that the units are the same when calculating the area. So here we have millimeters and millimeters. Figure 1c, this is a circle. Now what you notice about this circle? Well, we can see that the 5 centimeters with the dotted line represents the diameter. So in this case, we need to calculate the radius. And how do we calculate the radius of a circle? You remember, we recall that it is half the diameter. Figure 1D is our triangle again. And we have the height, which is 2, and the base, which is 7. 3, 5,1, and 7. If we add those three sides up, that would give us the perimeter of figure 1D. But to calculate the area, it's half base, which is 7, times the height, which is 2. In figure 1E, now in this figure, if we had to calculate the area of this figure, we do not have a formula for an L-shaped figure. But we can see that if we divide this figure into rectangles, then that would be a good way of determining the area. So what we are going to do here is we're going to look at how we divide figure 1E into two rectangles. Okay, so looking at figure 1E, right, in figure 1E, we are looking at the rectangle. And in the rectangle, we see that I've divided it into A and B. We enlarge that there. Right. So we have a rectangle A, and to calculate the dimensions, I've got 2 centimeters, and to calculate this distance here, I notice that the whole distance is 4, whereas this distance is 1,5. So it's 4 minus 1,5, and that will give us 2,5 centimeters. For figure B, we have the breadth being 1,5 and the length being 5 centimeters. So we simply add those two shapes, the area of A and B, to get the area of figure E, which is 12,5 centimeters squared. Okay, so you would be required to, right, let's go on to our worksheet. Figure F, we see that we have a rectangle and a semicircle attached to it. So in this case here, we are now going to add the areas of a rectangle and a semicircle. Now the problem is, for the rectangle it's 4 by 5,5, but for the semicircle it would seem that we do not have any measurements. But on closer inspection, if we look at the semicircle, we would see that the 4 centimeter transferred down onto this line here would become the diameter of that semicircle. Hence, the radius of this semicircle here would be 2 centimeters. So as you can see how I proceeded to calculate the area of figure F. So it's A plus B, which is shape A and shape B, which is length and breadth plus a half pi r squared. Now it's important to note that it is a half pi r squared, since we are working with a semicircle, which is half of 3,14 times 2 squared, and that is 6,28 on its own, added to the rectangle, which will be 4 times 5,5, and that gives us 22 plus 6,28, 28,28 centimeters squared. Good. Now class, as you know, when we look at our exam papers, it would involve more intricate calculations and different shapes, wooden, physical objects, and in terms of the real life situations like plans, floors. So all of that that you did previously would be incorporated into this section. If you look at example 2, we are going to look at the dimensions as being the inner figures that is drawn on a page. So we have the outer part is the page. Let's assume that's the page. So they say that the shaded area is the bathroom, which is 2,2 by 0,9 meters. If the bathroom is going to be, the shaded area in the bathroom is the bath. In fact, this 2,2 to 0,9 is the bath. If the bathroom is going to be tiled, what area of the floor will be tiled? Now, it makes sense to think that this is the bath and this would not be tiled. So we have to exclude that area from the tiling. So that poses the question now, how do we calculate the area of the remaining surface, which is again an L-shaped figure? If we look at it, we have got a 2,2 meters, a 0,9 meter dimension there. We have a 3 meter and a 4 meter dimension. Now, if you recall, going back to worksheet 1, we had areas that were within shaded areas where we had to do a subtraction in order to calculate the area of the shaded part. Now this is similar to this example here because the shaded part is what we need to calculate. So if we look at this example, we could see that if we calculate the area of the entire bathroom and subtract the area of the bath, that would leave us just with the shaded area or the area that needs to be tiled. So how does that look in terms of our calculations? So the area of the rectangle minus the area of the bath. So the area of the rectangle is 4 by 3 minus 2 by 2 times 0,9. And that's 12 minus 2,25, which is 9,75 square meters. Let's go back and look at that. So it's 4 by 3, the entire rectangle, as if it had no bath there. Subtract the area of the bath, which is 2,2 times 0,9, would leave us this shaded part of the bathroom. Good. I hope you are going to practice with all these examples and the booklet as we go along. Remember, you need to work with your booklet and continue with your work in the other pages. Okay, same on page 3. We have a picture frame. The shaded part of the picture is the wooden frame, and the unshaded part is where the picture would be situated. So we are saying that here is the picture. Okay, we want to calculate what are the dimensions of the picture that will fit inside this picture frame. Now, what we are told is that it has a border around the picture. And if we are given the dimensions of the border, which is 15 millimeters, the border measures 15 millimeters. Okay, that was omitted. So the border right round is 15 millimeters. Now, if we want to calculate the dimensions of this picture that will fit inside this picture frame, we are talking about this white part here, this white drawing here. Now, if I look at the entire length, it's 175 millimeters. And on either side of it is a 15 millimeter border. So hence, to calculate the dimension of, let's just call it X. And we'll call the other side Y. So if we want to find X in that shape there, we have to take away 15 millimeters from both sides evenly. So it will be 175 minus 15 and 15. Likewise, if you want to calculate Y, it will be 135 minus 15 millimeters minus 15 millimeters twice. So once we do that, we are able to determine the length and breadth of that picture. So the length is 175, subtract 15 by 2, which is 145 as we discussed. The breadth is 135 minus 15 times 2, which is 105. So that makes the second question very, very easy. In the second question, we are being told that we need to find the area of the picture that fits inside the picture frame. Do we have the length? Yes, which is X. Do we have the breadth, which we just found, which is Y? So going back to that area, that question, we find that the area in square millimeters will be 145 times 105, which is 15,225 square millimeters. A question I want to pose to you. What would be the answer in square centimeters? I need you to think about that. Write that down. What would be the answer for B in square centimeters? And how would you calculate, how would you determine that? Convert 15,225 square millimeters into square centimeters. Because sometimes we are required to calculate that and convert our dimensions. Good. We are going to go on to question 4. Right. Let's go on and look at question 4. I'm sure you are now getting the idea of what we have at hand. In this picture here, we have a plot of land, and as you can see, there are measurements given on this piece of land: 8, 6,4, 7,2. This one here is missing. I will call that X. That's 3,3 from there. That's 4, and the whole long bit here is 13,7. Now they want to put a fencing around this land, so I need to find out how many meters I will require. What concept are we talking about here? Well, that is the perimeter of this piece of land. If you want to calculate the perimeter, the 8 is, we add the 8 to 6,4 to 7,2. I'll come back to this measurement here. 3,3, 4 meters at 13,7. But to find this measurement from there to there is a bit more complex, because as we can see, we have a 4 meter dimension and an 8 meter across. So this measurement here, if I look at it there, it's 4 meters there. So if we go up there, it is 4 meters. So from here to here, it will be a 4 meter added to 6,4, which will be 10,4 meters. So as we see that, it's 8 plus 6,4 plus 7,2 plus the 10,4 plus 3,3 plus the 4 plus 13,7. I'll leave you to add that dimensions and calculate the perimeter. So to calculate the area of this piece of land, as we did before, we divided into smaller pieces, A, B, and C, and each one of them represents a rectangle, and then we calculated the area using length times breadth. Well, all the dimensions you had figured out from that figure that we were given. The last bit in our question paper is a figure which is similar to the one with the bath, but now we have a pool in a garden. So we have, there's a pool, there's the rectangular garden. Question 5A says, how much area of the garden will the pool take up? So in other words, just this circular pool, what area would it take up? So that involves finding the area of the pond, which will be 3,14 times r squared, which is 1.3 squared. Substituting that into our formula, we get 5,31 meters squared. The next question in our paper is, if Cindy is going to plant grass on the garden surrounding the pool, what area of grass will she need to buy or plant? Now, obviously, she can't plant the grass in the pool, so it'll be all the area around the pool and all this vacant space here. Just as before, we would assume that there is no pool there and calculate the area of the entire rectangle. And from that, we will minus the area of the pool, which we did find in A. So what I've done was I've calculated the area of the rectangle minus the area of the pond, which is 5,31. So it's 5 times length and breadth, which is 5 times 3,6, which is 18 minus 5,31. And we need to calculate that answer there, which is 12,69 meters squared. You can check that answer there. Right, learners? So we have completed page 3, and in our next lesson, I would want you to practice and do an activity, which is page 4. Do the activity on page 5, and we will correct that in our next lesson. And also, you can read up on page 4. Okay, till next time.